Hello everyone, hope all of you are doing good. In this segment, we'll deal with how to calculate the hydrostatic force and the location of center of pressure for the vertical plane surface submerged in liquid. Remember, we are in a series related to the hydrostatic forces. Let us consider an irregular body of this order, and G is the center of gravity, P is the center of pressure, and this is the free surface. That means this irregular body is submerged in liquid. Okay, now there are two distances as far as the free surface is concerned. One is the distance from the free surface to center of gravity, that is h bar, and the other one is distance from the free surface to center of pressure, that is h star. Now on the other angle we can look this irregular body as a straight line. Now F is the hydrostatic force which is acting on the vertical plane, and this F will directly act on the point P. Okay, let us consider a micro strip with the B as the width and DH as the thickness, and this is the rectangular elemental strip. So H is the distance from the free surface to this elemental strip. Now, having said that, we know the definitions of H bar, G, P, H star, and F. It is now the time to understand something related to the hydrostatic pressure force in the vertical plane surface. Now, P is rho into G into H, or P is gamma into H. And whenever we consider this microscopic elemental strip, it's dA, the small area. dA is nothing but B into dH, which is evident from this diagram. And then dF equals to P into dA, where P is rho into G into H, and dA is B into dH. So finally, if we know the values of small forces dF, and if you integrate upon those small forces, you can get the total hydrostatic pressure, hydrostatic force. So F is integration of dF. Now what is dF? dF is rho gh B into dH. So rho g can be taken out from the integral sign, so it's rho g into integration of h dhb. Now what is dh into b? It's dA. So the integration of h into dA is nothing but moment of surface about free surface of the liquid. It has certain extended meaning, and it's about A into h bar. H bar is the distance from the free surface to center of gravity. So that's how we derive the equation for the total pressure F equals to rho into G into A into h bar. Remember, A is the surface area, h bar is the distance from the free surface to center of gravity. Now it's our job left out is to calculate the position of center of pressure, where exactly F is acting, the location which can be expressed from the free surface to point P, and that's about distance in terms of meters, which is nothing but h star. Now if we can go with the principle of moments, one can very easily write F into h star equals to integration of df into h. So on the right hand side, it's the summation which is expressed in terms of integration, and on the left hand side we have F, which is the prime force here, the hydrostatic force, into the distance, which is h star. Okay, so integration of df into h is nothing but integration of rho gh b into dh into h. We have done with this part. So rho into g into integration of, there are two h's, and upon the multiplication it is h square now. So it's rho into g into integration of bh square dh. Now remember, b into dh is once again it's dA. So do you know the meaning of integration of h square dA? If not, it is I naught. I naught is moment of inertia about this axis O. So F into h star is rho g into I naught from the previous simplification, and F is rho into A, G into A into H bar. Now there is again H star here, which is equals to rho into G into I naught. But we can also shift the axis. We can also calculate the moment of inertia with respect to the GG axis through center of gravity, an axis passing through center of gravity. That's the meaning. So I naught equals to IG plus A H bar square, and we can express I naught in terms of Ig. That's the meaning of this expression. So H star is I naught by AH bar, and if you simplify and if you substitute for I naught in terms of Ig, H star becomes equals to Ig plus AH bar square by AH bar, and the further simplification will yield a value of H star which is equals to Ig by AH bar plus H bar. And that's about the final equation. For the position of center of pressure, H star is Ig by AH bar plus H bar. Now one should understand a very important fact here is that H star is always more than H bar at least for a fraction of this Ig by AH bar. And H star is expressed in terms of meters, the distance or the unit of a distance. Thank you.